My name is Lorraine Wong, and I am the current director of CIG. I'd like to welcome you and thank you for joining today and participating in our very first virtual business meeting. Most of you are probably pros now at Zoom, but just a reminder that please use the chat window to communicate with us and others, and raise your hand and turn on your camera if you wish to speak. That way we won't miss you. I would also like to remind you that participants in all CIG spaces, whether in person or virtual, are expected to abide by our principles of community, which can also be found online. Okay. We have an ambitious agenda today. We'd like to update you on this year's past activities from headquarters and community projects. We'll also give you a quick overview of the CIG proposal currently under review, and then break into breakout groups on 2 topics, centering on CIG's part in JEDI and belonging, and a general discussion on engaging our community. We'll end with a plenary discussion on how we position ourselves to support Earth system science and convergence research going forward. Okay, in the past year, we've had some staffing changes. Renee Gasson-Miller serves as technical lead for the organization and will retain this role in CIG4. Hiro Matsui remains on staff managing our exceed allocation and improvements to the code Calypso, including in situ visualization on TAC Frontiera. Through our postdoc program, we were able to recruit 2 excellent postdocs, Kali Allison, who is working on adding earthquake cycle capabilities to Pilot, and Ryan Orvidal, who has worked on improving the spherical harmonic transform in Rayleigh and implementing hybrid CPU-GPU computing. We're also very happy to have on board Chris Mills. Chris is a recent graduate, having completed a senior thesis with Max Rudolph using Aspect. He's helping us with converting the Pilot manual to online documentation, and hopefully we'll get him started on Jupyter notebooks earlier in the new year. Okay, recent elections. Okay, before announcing our new members, I would like to begin by thanking members of the EC and the SSC who are rotating off, and everyone who has volunteered their time during the last 3 years through a period of change and transition for the organization. And many thanks to our nominating committee for putting together an excellent slate of candidates for this year's election. Okay, for the EC, our incoming chair is Claire Curry, and we welcome 2 new members, Brad Agard and Carolina Lithgow-Bertoloni. For the SSC, our incoming chair is Julianne Danberg, and we welcome 4 new members, Ebru Bosdag, who's actually returning, Peter Driscoll, Harriet Lau, and Dave May. A major activity for governance this past year was to define the roles and responsibilities not only of the EC and the SSC, but also for working groups. As specified by the bylaws, the EC is primarily responsible for administrative oversight of the organization, and the SSC at science, software, and cyber infrastructure. We've had discussions on how to execute these charges, and they resulted in several documents outlining the roles and responsibilities for each group that have been posted to our website under About Governance. So if you're interested in running for elections or starting a working group, that's where you can find these documents. For the working group, the committee addressed several questions, including why we have working groups and their expectations and incentives. And as you see here, working groups can have many roles, from providing advice to leadership, identification of needs of the community, as well as driving the solution. To that end, we have 2 new working groups forming that we are looking for committee members, also known as volunteers. We have a workshop committee for the upcoming annual Software Developers Workshop in February, and we are also looking for members for a new working group on seismic cycles. Please contact me or the leaders, Brad Agard or Sylvain Barbarabo, if you are interested in joining either of these efforts. This brings us to what events we'll be hosting in 2022. In 2022, we plan to bring back a full slate of events, virtual and in person, and probably somewhere in between. Please sign up for the forum so you do not miss these announcements. We would like to think that COVID is behind us, but there are more than likely will be some further adjustments we'll need to be making, as well as confirmation of dates that are still pending. Our distinguished speaker program continues. This year we've had 2 excellent speakers, Adrian Lenardic and Tolu Oluboji. This year the program has expanded to virtual visits to international institutions as well. We hope to bring back the S'mores program. This is our REU pilot project, and we are actively recruiting for mentors for 2022. You'll learn a little bit more about that in a couple of slides. And webinars are back. So we took a hiatus a bit last year, but in 2022, we will bring you a full slate of webinars from a group of young researchers working on actively sponsored CIG projects. This includes the kickoff webinar, which will be on AVNI. AVNI is the Analysis and Visualization Toolkit for Planetary Interfaces. You can learn more about this project in Raj Mulik's January 13th webinar. You'll also have opportunities at a later date to provide feedback as the project advances. He'll be developing some outreach and tutorial materials, and we hope to engage the community in learning about what they think they would like. We are also excited to be a collaborator on the Scoped project. This Cypher infrastructure project aims to bring greater access to HPC and cloud computing for applications in seismology. You probably recognize many of the PIs pictured here, so expect to hear more about this project in the coming years. We are also very excited to be rolling out a new website early next year. Some of you may have noticed that we've been sneaking in some new branding over the last year. The homepage will look like this. There'll be a new way to download and access metadata on software. There'll be wikis for project support. There'll be the ability to both contribute and find publications, also known as citations, that use our community software. There'll be a unified calendar, more reliance on the forum for communications, and a user-accessible ticketing system. The website has been developed by the Hub Zero Group, which originated through NSF to support science gateways. So look out for a webinar and a soft rollout very soon. So this brings us to the project reports portion of the presentation. I'm going to hand over the mic to John Dalaboff.
Great, thank you, Lorraine. And so this was a program which Lorraine and I had thought about for many years, and others at CIG, about starting a pilot program for both undergraduate research and then also a framework for future CIG training for either advanced undergraduate students or early graduate students. And so first I would like to acknowledge that Dave Stegman played a fundamental role in helping us develop this program and run it as well. Oh, and also we would like to acknowledge the CIG SSC members, Sylvain Barbeau, Krista Sutherland, and Keen Wilson, for helping us to provide independent reviews of all of the applications. And next slide. So why do we run this program? What were sort of the motivation and the challenges to the community? So then there are many fields which people come to from geodynamics in their undergraduate, but many of these fields and our field as a whole in geodynamics are some of the least diverse in STEM. And equally as challenging is that there are too few undergraduates with proper numerical and computational backgrounds. I think this is a challenge all of us have addressed in training incoming graduate students. So our idea was that one way CIG can help with all of this is provide funded training and research opportunities for undergraduates from a wide range of background. And in this program, what we specifically did was heavily target underrepresented groups in our advertising. Next slide. So there were a total of 35 applicants. We selected 5 students. I should acknowledge that one of the students, Kaneni Godana, was co-sponsored by another RU program, and we had a large number of mentors from a wide range of institutions. I won't go through the list of names because I think everyone here is very familiar with them. But one thing we did, in part because this is a virtual program, is we actually used a team approach in assigning mentor pairs. So then the way the program worked is, this was the structure. There were 2 weeks of virtual tutorials, and this is what we covered: the basics of Python, geodynamic, fundamental geodynamic processes, and then also geodynamic modeling. The geodynamic modeling was done through aspect tutorials. Then after that, there came 6 to 8 weeks of research projects at these different institutions. Again, although this was all done virtually, but then we met weekly, and this was to provide, we met weekly as a group. This was to provide project updates, tips for graduate school applications, a wide range of topics. And then I should note that the topics that were focused on in the research project could range from mantle convection, mountain volatile transport, all the way up to long-term tectonics. And the next slide. So then the question is, overall, we we very much thought it was a success, especially given the challenges associated with doing a virtual tutorial and a virtual research program. Overall, we thought there was a very high quality research which came out of that. And out of all the RU projects, or out of all the s'mores projects, I should say, and that if you'd like to view the last CIG webinar in October, all the students presented their research there. So the question going forward, and this is probably the most important thing in considering CIG 4, is first, do we run the same research program next summer? If we do that and people are interested, we're certainly going to need a new program leader and additional mentors. And if this does happen, I think it would be a good idea to extend this to more areas of the geodynamics community. So short-term tectonics, geodynamo, this was very much in 2021 a pilot program, but if we run again, I think it would be good to expand it to the entire CIG community. Probably most importantly, I realize I've said that a few times, is that originally the idea was to have that 2 weeks of training at the beginning of the program be available to all members of the community. So it was going to be a broad tutorial that primarily graduate students could apply for, but this year we just didn't have the resources to put together that tutorial of that scope. And in this case, it was just done through the combined efforts of all of the mentors. So what I'd like to end with is for actually 2023 and beyond, this is what I think the CIG training and RU program would look like in a perfect world. First, there would be funding from NSF RU program to support a large number of students distributed across the community. The program officers have made it clear that a specific RU program needs to be separate from CIG, and this is all certainly possible. But where CIG can contribute is that we would begin this program with 2 weeks of tutorials that would be hosted at CIG headquarters, possibly in combination also virtually. I think the first week it would be really helpful to begin with a review and sort of outline of basic computational methods in geodynamics. This could go anywhere from the basics in Python to visualization to running different geodynamic software. Then in week 2, there could be a choice of domain-specific tutorials. So this could be like the classic PyLith or Aspect tutorials, maybe extending out to Rayleigh and SpecFem and other codes. And this would be available to all members of the community. So that is basically a straw man proposal for people to think about going forward and how CIG would like to structure sort of fundamental training each year, and whether or not it makes sense to have a broader NSF RU program associated with CIG in some form of collaboration. Great, that's it. Thanks, everyone.
Great, thanks a lot, John. And as John mentioned, we are actively recruiting for mentors, and we would like to have these lined up early in the next year. So please contact either John or me for more information if you're interested. I think the students we've had this year made tremendous progress. We've had senior thesis come out of it. We'll also have some presentations at AGU. So we're going to transition now. I challenged our community software groups to talk a little bit about their software projects and about past and future perspectives for each of them. So first up is Brad Agard, who is representing the Pilots Development Group.
We can go on to the next slide. The primarily developers, maintainers have been myself, Matt Nepoli, and Charles Williams. Sort of just by the numbers, we've since 2007 when we started started releasing of Pilot. We've had seven science workshops, and that doesn't include about 3 or 4 workshops that preceded Pilot development in the short-term crustal dynamics area. 12 tutorials. We have 2 hackathons, 32 releases of Pilot. Obviously, that includes major releases, minor releases, as well as bug fixes. We've had over 8,700 commits, and across our last 10 releases, we've had over 10,000 downloads of our manual and similar numbers for our binary packages. Next slide. So looking back, how far we've come in the last 14 years, we have a much better user experience. We have binaries now for Linux and Mac OS that we maintain. We have an installer for building from source. We have a few hundred-page user manual with lots of examples. Also includes the development of the governing equations and numerical methods information. Our error messages have become much better. And we've also established sort of a Docker container for development that simplifies getting people up and running with the code when they want to do development. That applies currently for our main development branch. It doesn't apply to our previous release. We have much better code now, more extensive use of PETSI for spatial and temporal discretization, data structures, solvers, improved modularity of the code. We have multiple levels of testing, unit tests, method of manufacturing, solution tests, full-scale tests. And we've also, as the tools have evolved over the last 14 years, we have a much better development workflow. We're using Git branches with pull requests that, we started out with Subversion and primarily just one development branch. Next slide. So look, where are we now and what are we looking forward to? We're looking forward to an even better user experience. As Lorraine mentioned, we're well on our way to migrating our documentation from a LaTeX that produces PDF to online documentation built using Sphinx. We would like to progress towards Jupyter-based examples that are much more sort of interactive and everything is in one place rather than having to go between the manual source files and additional READMEs. We'd like more research level examples to really bring people up to speed to using Pylith in their research. We have in the process of developing open source meshing options, and we'd like to provide containers for clusters so people can get up and running with Pylith on a wide variety of their own clusters much more easily. We also have big plans for the code itself to have even better code. One of the main things is now that we have a multi-physics implementation, it's easier to specify the governing equations, but it's a fair amount of work, and we want to auto-generate a lot of sort of the pointwise functions that implement the physics and make it much easier to compose new models from existing models and so forth. And we continue to want to improve the efficiency, scalability, and optimization of the code itself. And next slide. So finally, we're looking for new capabilities. We're starting to work on earthquake cycle modeling, and specifically we mean coupling quasi-static and dynamic problems by projecting the solution and state variables from one discretization to another. We also want to do data assimilation using adjoints and continue to build up our pro-elastic capabilities by moving into not just the bulk, but also fault rheologies. We want to continue to develop or build our developer base with more hackathons to facilitate user contributions and continue to leverage postdocs and internships to expand developers. And I just want to highlight this, that USGS and NSF have a joint program that if you are funded with NSF funding, you can apply for USGS internships to cover visits to interact and collaborate with USGS scientists. That could be me, or it could be other USGS scientists. This is an underutilized program that has a rolling enrollment. So if you have grad students that want to make use of this, particularly for Pylith, please contact me. That's it. Thanks.
Is there a link somewhere for people if they're interested in this program?
I can come up with a link. It's not always easy to find things like this on the USGS website.
Exactly. Thank you so much, Brad. Okay, moving on is Yaron Trump. He'll be representing the SpecFem group.
Hello, everyone. You can go to the next slide. So I'll talk about SpecFem 3D and SpecFem 3D Globe. So we were asked to look back. So we've been in this business for quite a while now. And what I find the greatest challenge in academic software development is to keep the code stable and portable and well documented and making sure that all the examples work. And the problem is that graduate students and postdocs, they come and go and generally have little training in proper software development, testing, documentation, and maintenance. So to bring people into the group, to train them properly, to make sure that they do things well and don't break things, and find things if they do. Those are the really big challenges. It's not trivial to take these codes and install them. So finding ways in which it becomes easier for users to just take a containerized version and install it somewhere is the way to go forward. And then the other thing I found really beneficial and enjoyable are education and training workshops. So we really should be doing it more often than we do. And often they're really great when you do it as part of another meeting. So for a while there, we had a really good collaboration with the SPICE and Quest programs in Europe. But it would be good to find a way to go back to having regular meetings so that there's lots of opportunities for new people to begin to use the software. Yeah, and so part of the challenge of maintaining the workshops too is that for a while there's a group of students or postdocs that are very enthusiastic about helping with these events, but then they move on and maybe it becomes a little bit more difficult with another group of students. So to get stability is the challenge. The other thing that I wanted to make a point of is that these days for us, it's not really so much about SpecFam and SpecFam 3D Globe, but the peripheral software, everything that you need to actually do science that goes with these codes is just as important. So for example, to do adjoint tomography, there's a very extensive software base that is constantly evolving and that is just as fragile as the source codes themselves, perhaps even more so. We are using these tools to do large-scale inversions at national supercomputing centers, and often it's very challenging to do that because the hardware goes down frequently. Every hour, every few hours, there's something and you tend to lose jobs. So when you do things at scale and you invert for thousands of earthquakes, you need to have a way of keeping track of what worked, what didn't work, and not by hand. So this is where we found that having proper workflow management tools, and NTK is an example, but there are lots of other things out there, I guess, they can really help stabilize these workflows, and they've been really important for us. And I imagine that they will be for other users too, for example, as PyLift develops adjoint capabilities. So looking forward then, keeping the previous comments in mind, we have decided to help to tackle this problem of software development and stability, to begin a collaboration with a team at Sandia/Oak Ridge called COCOS. That's part of a DOE exascale project. And it's a really serious, large-scale effort to sort of properly do code development. So it's a C++ programming model for developing performance portable applications targeting all the major HPC platforms. And it seems like a really great group. We've had a very good start to this collaboration. We're in the process of trying to find a person who will be participating in this. But I'm mentioning it because it may also be something that is ultimately of interest to other code developers at CIG. And I'm happy to inform people about our experiences as we move forward. So the way we're planning to do this is to hire a dedicated research software engineer to be in charge of this, this project. And a challenge with these people is that it's often lonely. And the way we're trying to deal with it on the Princeton campus, we actually have a group of these research software engineers. They're centrally managed. They're part of the Princeton Institute for Computational Science and Engineering, where they spend a bit of their time. And then they're farmed out or deployed across the campus to work in specific research groups. So we're trying to make it more interesting for these people to develop a little bit of a community. And this is another challenge that we've at least found over the past years, is to find and retain these people is is not easy, and this is one way we're trying to cope with it here on campus. One last slide, I think just a couple of things scientifically, even though we're told not to say too much about it. One of the things we're continuing to work on is full gravity in our solvers. So that means coupling conservation of linear momentum with the Poisson-Laplace equation. It's tricky because the Laplace equation is defined in all of space. So the way we do it is we combine spectral elements with infinite elements. It's a very elegant numerical solution. We've benchmarked these approaches for co-seismic and post-seismic deformation and for gravity perturbations. And we're currently working on a frequency domain full gravity free oscillation solver. That's pretty close. So that's a continued collaboration with Hamnat Garti, who just recently took a position at Queen's University in Kingston. And then future developments based on this approach will also address problems in post-glacial rebound, sea level variations, dynamic topography, and tidal loading. We've sort of touched on these kinds of problems, but we haven't really worked on them seriously. And so we're hoping to develop a tool that can be used for these types of scientific problems. And that's my quick summary.
Thanks, Jeroen. A lot of really interesting stuff happening there. Next is Nick Featherstone, who's representing the Rayleigh Group.
Thanks for putting the little SORI logo down there. Yeah, you can move on to the next slide. Yeah, so just a quick summary. So Rayleigh is CIG software that was actually, whose development was fully supported by CIG. It wasn't something that was brought to CIG to be supported. It was developed through CIG. I was the primary developer for several years, but I have some help now. It's targeted at the geodynamo. It's a pseudospectral MHD code that operates in spherical geometry. So using spherical harmonic basis functions and also Chebyshev polynomials in the radial direction. It operates in either the fully incompressible Boussinesque approximation or in a kind of semi-compressible anelastic approximation. From a serial standpoint, Rayleigh actually draws on work that Gary Glatzmeyer did many years ago. In fact, I believe one of his codes, MAG, was one of the earlier CI. But the real part is that it's very efficient in terms of its parallelization. We can run on many thousands, tens of thousands, hundreds of thousands of cores. One of the things that we done in CIG 2 and 3 was to run on the inside machines, particularly Mira. Sorry, Zoom's telling me my internet connection is unstable. We had an initial release, kind of a beta in 2016. So if you knew me or knew somebody that on the working group, you could get a copy. The public, the first really fully open public release was in 2018. As far as we know, there's a good number of people using it in terms of broader impacts. For example, I know of 6 PhD theses that have either used Rayleigh or are using Rayleigh. Ryan Orvidal, who recently joined CIG, used Rayleigh heavily for his thesis work. There's been a number of undergraduates that use it. Mike Hawkins at CU in particular hires a lot of undergraduates and they work with the code. I've also mentored a couple of students in the LASP and HAO REU programs. And then kind of moving beyond the geodynamo, I mean, my own specialty actually is stellar convection. So Rayleigh is used really by anybody who is interested in convection in a system that rotates and in spherical geometry. So if you're interested in stars or you're interested in planets, and a lot of us actually kind of work in both depending on the time of the year. Rayleigh is used in those areas as well. So, Moritz Heimpel, for instance, is using it to study Jupiter. Krista Soderlund has looked at some ice giants with it. I look at the sun. Another broader impact, I'll just mention something that has really come to fruition here lately, but which has its roots in the InSight project that we have. So there's a mission being proposed, and it's in the final stages of the selection process now, to send something that's very much like MDI, if you remember this at all, but have a Doppler imager and an EUV imager out to Jupiter and then use Jupiter to get into an orbit that's out of the ecliptic. And so it'll actually fly over the poles of the sun and image the poles and take Doppler measurements of the poles. And some of the really heavily into the scientific mode for this 2 years in the step 1 proposal, where we were selected for phase 1, and we had a site visit last week. And I think the 3rd or 4th slide that the PI showed to NASA was actually showing movies of Rayleigh results as part of the justification for this mission. Piece of it, but a substantial piece. So I think just be aware of that if you're ever writing, you know, a report or something. I think this is a real broader impact. As far as the community goes, we started having tutorials back in 2016, right at the start of CIG 3. So we've had 2 of those, and we've had 3 hackathons. The last one was this year. It was virtual. We didn't have one in 2020 just due to COVID. But those have been very successful. If you move to the next slide. The picture from our very first hackathon and kind of tutorial workshop all mixed in together. So this was held at the University of Colorado back in 2018. And this kind of gives you a sense of the user pool of Rayleigh. I would say at any one time, it's something like about this number of people that seem to be using it based on who emails me questions or who tunes into a user meeting. Some of the names and faces rotate in and out. And some of them have stayed pretty steady over time, but we've got a pretty solid community now, which brings me to my next point on the next slide. I would say this project is really coming online now. We're in the sense that we have critical mass. We established a core development team this fall, and that's comprised of Philip Edelman, who's at Los Alamos, Renee Gasmoyer, who's with CIG and at the University of Florida, Lauren Matilsky, who's at CU, Ryan Orvidal, who's at Davis and CIG, and Kian Wilson, who's at Carnegie. This crowd has really been helping me both in terms of implementing new features and approving pull requests. And so we're kind of finally organized as of this fall. And actually as part of that, while you might say Rayleigh 1.0 has been out for a very long time, just this month created the official release of this. It's got online documentation on Read the Docs and all of that as part of the source code repository, so users can easily edit the documentation in addition to features of the code. And our plan is to have quarterly releases that we're going to shoot for this moving forward starting in 2022. So hopefully in March, we'll have a Rayleigh 1.1 with whatever improvements or bug fixes have happened now. In terms of community engagement, we want to keep having hackathons. We're going to have open monthly user and monthly developer meetings. We've kind of just been meetings for them this fall while we get organized, but the plan is to sort of stagger these 2 types of meetings starting in the spring. We also have a checkpoint repository that we've started with Rayleigh, so that if you don't have access to, tens of million hours, you might be able to grab a checkpoint from somebody who did from an equilibrated model that fits into your parameter space. We've got just a few publications worth of checkpoints in the moment, but we're working on kind of in the site involvement. Mike Hawkins and Nick Nelson, who's at Chico State, and I are trying to get kind of a yearly workshop set up looking at rotating convection with undergraduate students, and that will be leaning heavily on Rayleigh. Longer term, I would say probably the first priority at this point is to make the code GPU capable. We have some ideas on how to do that, and Ryan Orvidal, who joined CIG this year, is spearheading that effort. If we can do that, that certainly opens up other machines and sort of the national supercomputing landscape to us, like for instance, the Summit machine out at Oak Ridge. We're also interested in some more sort of detailed things that I won't belabor, but sparse matrix formulations. There are issues where as we move to larger and larger problems, the matrices just take up a lot of memory, and moving to a sparse formulation for some of these could be useful. We have some ideas on how to do that. Physics improvements. A lot of these are sort of driven by what other users are asking for. I would say sort of 70 to 80% of the users just run a standard problem setup, and they change the Rayleigh number, the ECMA number. But every now and then somebody wants something a little bit out of the ordinary. We try to be responsive to that as much as we can. And so just some ideas down here, but that's always an evolving topic. And that's all I have for Rayleigh.
Great, thank you so much. We'll look forward to hearing an announcement about the Solaris mission. I should also, yeah, cross our fingers. We should also note that there, the seismology codes are also being used in planetary on some of the missions. That is the InSight mission. There's a lot of seismology being done, looking at the interior of Mars. So that's been fun to read those papers. Okay, so our last project report is from the Aspect group, and Wolfgang Bangerth will be representing that group.
Sure. So Lorraine asked me to stick to 5 minutes, and I decided that I'll just skip all of the technical details and just focus on sort of what I think that I learned from building Aspect. And I should also say that I'm not speaking for myself, but I think at least I hope I speak for the whole community. Aspect has a very different development model in that the number of people who actually contribute code is much larger than I think for most of the other projects, that there's not one place where let's say 2 places, like in the case of Pineless, for example, where most of the code is developed, but it really comes from a much bigger community. So the way I see Aspect is that we wanted to build a mantle convection code, and we ended up building a platform, and that's actually been quite an interesting journey, something that I really enjoyed, and I think that a lot of people in this project really enjoyed. That we found that we can do a lot more things if we just provide a platform that people can use for whatever they have in mind. And, over the years, the biggest fun in this project is really to see what people do with it. Things that we didn't expect. People add physics to it. We have people who've expanded from the mantle into the crust with a much more difficult rheology, for example. And I'm going to show something on the next slide. But then also we used Aspect as a tool from which we can learn how to build communities, how to educate people, how to teach this sort of stuff. So it's a tool for us to learn something about learning. And I think from the perspective of CIG, at least, Aspect has been something that has, at times developed approaches that then flowed into how other projects do it. And I should add here that this actually goes both ways. I mean, we've learned a lot of things, for example, from how the Pineless people do community and workshops, and some of the other projects too. And so the point I want to make is that it's a two-way street, but Aspect is also a tool that allowed us to experiment with things that then are helpful to the rest of CIG. So just to illustrate this first point, that people do things that we had never in mind when Timo and I started this 10 years ago. So we really thought of this as a classical mantle convection code. So we thought of the mantle as something that starts, I don't know, 50 kilometers down and goes to the core mantle boundary, where you look at sort of the classical plume models. And what we ended up doing is something that turned out to be a fortuitous design choice, that we parameterized basically everything, and we had plugins for the geometry, for the material model, and so on and so forth. And that has allowed a lot of people to do really cool stuff. So people to parameterize the materials that go with crustal dynamics, for example, or couple with surface models, or do post-processors that we don't write, but that other people write for the research projects, and that then end up in Aspect without actually very much work on our side. So there's a lot of really cool stuff over the years where I think the technical design that we chose in the beginning has allowed to use this code for for really interesting things. And one of those is on the next slide. So it's a model that looks so crazy complicated that you think it's a cartoon, actually. So it's something that was in the CIG newsletter last month, where Derek Neubarth and colleagues coupled the aspect for the volume evolution with a surface model that uses a code called Fastscape. And if you look at the video for this, it's just amazing to see how complicated this is and the dynamics of this, things that I think we all seen from seismic images and from drawings. But this picture is actually a real simulation. And I think this, to me, sort of epitomizes that I don't think 10 years ago we had any idea that something like this could be simulated. And I think that 5 years ago we had no idea that this could be done with Aspect. And I think it makes all of us who spend time on this code really proud to see that a whole bunch of people, so there's 5 authors on this paper, only one of whom is actually a principal author of Aspect. The rest of them just figured it out. And I think that to us is sort of a really interesting lesson learned from how we do this. So from my perspective, it's a serendipitous software design question of how do you write a code that enables these sort of things. The second point I want to highlight is that Aspect for us was originally a software project, but it turns out that over the years, with as many people as have contributed to it, I mean, many of those are here on this call, that has turned into a really interesting educational project too, right? That we've written a huge manual with a lot of cookbooks, also contributed by, I don't know, 30, 40 people over the years, and the list of authors of that manual is huge. We've experimented with user workshops prompted by the way Pilot has been doing this for many years. Then we've experimented with our own idea. This was the hackathons that I think are flowing into other codes. And then we've built classroom material and workshop material that many of us have used. Not just me, but I would say there's at least a half a dozen people who've used these sort of materials for various teaching workshops in many countries around the world. And I think that's really interesting to see too, that this code that was originally meant to be just a software project is now also an educational project. And it allows us to teach things that maybe we didn't really have in mind before, for which there was no materials, and everybody would have written their own stuff and shown cartoons of how plumes look like. And now they just use our code as sort of a tool to actually generate these plumes computationally. Next page. So the other part that I think we've learned from this educational enterprise is that how much work it actually takes to get all of this organized. I talked to somebody recently about the Deal 2 documentation, for example, and mentioned that it is between 10 and 20 main years of work that has gone into this. And I think for Aspect, maybe it's not quite that much, but if you add up how much work it takes to write all of the cookbooks, to review all of the cookbooks, to write the manual, to write the documentation, to write all of the teaching material, it is a lot of work that goes into this. And is maybe more than anything else, the one thing where I know for a fact it without CIG support it would have never happened. And I think that's worthwhile stressing also to the sponsors, to NSF, right, that we really appreciate this because we are able to provide something for the community that would not otherwise have happened. People write code, they write it for their own interests. People do not write documentation, do not produce teaching materials out of their own interest. And I think that's something where CIG really has been very helpful. The other part is we realize how much education our students actually require in computational science, right? That the curricula that our grad students go through in the geosciences do not put a lot of emphasis on this. And so a lot of the education that we do provide are things that in a sense are quite fundamental. Like, how do you write little scripts? How do you write C++ code and so on and so forth? And I think that's also one of the realizations that for us has come out of this, that there's a need for this work to be done for writing all of this documentation, because the universities just don't do this for our students. The last point I want to make on the last slide, Lorraine, is you didn't copy my closing quotes on model. I think of Aspect as something that fortuitously has worked. We started 10 years ago, Timo and I, and I think, so Timo was a postdoc and we wanted to have a little research project for us to figure out how to do these sort of things for ourselves mostly, and maybe, yeah, I mean, it was supported by CIG, but we had no idea where we're going with this. And I think if I think back about the last 10 years, what it boils down to, what actually made it work, is that we ended up having the right people who are having fun with this project. And the older I get and the longer I think about software, the more I realize that the most successful projects are the ones that have the right people. And in our case, in the case of Aspect, it is by and large people who enjoy working together, who are not territorial about their own work, so are quite happy to have other people modify what they do, and who just enjoy the collaborative aspect of it. And I am so grateful for this community, and I think a lot of us feel that way, that we just really enjoy to work together. The other part that has gone right is CIG has continuously supported this, both in person and for the workshops that we've had. And we made the right technical decisions. I think most of us will probably agree that the majority of the technical design of Aspect was right from the beginning. And that's just fortuitous or maybe experience, but it turned out all right. We never had to really rewrite Aspect to support a lot of different things. The part that I personally find interesting is that people have been developing careers on Aspect and with Aspect. If you look at the principal developers of Aspect, for example, a lot of them started with Aspect when they were graduate students, and they're now in long-term careers, places where they can use the knowledge that they gained with it and the experience and the exposure to the community and turn that into something that's useful for them too. I mean, I might be the oldest, and it's probably been very helpful to me in my career, but it makes me proud that so many other people have found Aspect to be useful for their own careers. So to me, Aspect is also a tool to learn what works and what can be copied in other projects. And that's it.
Thank you. Thank you to all our presenters who have taken up the challenges of sort of having both a backward and forward-looking perspective on software at CIG. I've been involved with CIG coming on a decade now, and it's been really fascinating and fun to see how each of the communities have grown, and each of them have done it in sort of in slightly different fashions and how much they've learned from each other. And we certainly hope to continue that. We hope to come up with even more pleasant surprises as we head into CIG4. So Bruce, that is your segue to communicate to the community what is in the CIG4 proposal.
Right. Thanks, Lorraine. And so my goal here really is to give you a sense of the kinds of things that went into the CIG4 proposal, sort of illustrate what are the things that are perhaps a little bit different from what we've done in the past, and what are the things that are quite similar to things that we've done in the past. So maybe we can start by actually thanking the proposal writing committee. I can attest that these people worked long and hard over the last spring through many long Zoom calls. In fact, I think probably many have sort of an adverse reflex reaction to probably seeing my face on a Zoom screen. But really the input and the experience and the advice of this group of people really made the CIG4 proposal possible. We move forward. So to set the context, I think there are two things that we considered. One was the fact that this is a program that came through the geoinformatics program at NSF. This is a program that has supported CIG in the past, but this time around there were aspects or elements of the solicitation that were quite different from what we'd seen in the past. And in particular, they were a lot more specific and had a number of very targeted areas that they wanted to see addressed in the proposal. When we first got started, I think in the new year, I think there were 5 essential elements, and then sometime over the course, they evolved into the 6 that I'm showing you here. So the first one is the modern cyber infrastructure. They wanted to make sure that we were proposing technically sound things that used modern open source tools and clear experience with these approaches. So this is the kind of thing that CIG has been done in the past. They refer to engagement, and here really the intent is the community engagement. This is both the users of the cyber infrastructure, the scientific community, as well as encouragements to us to reach out to underrepresented groups. Science motivation was the thing that we started with, and our discussion on this point really focused on what we would consider the major scientific questions, tried to understand what the bottlenecks or difficulties in achieving those goals were, and what were the things that CIG could do to enable or accomplish those goals. They wanted specific ideas about how we were going to measure success. And maybe the biggest change, perhaps, from previous solicitations was a sustainability plan. So moving forward from here, the geoinformatics program is looking at being a program that would support new ideas, develop them, let them come on stream, and then have these things sunset so that new ideas and new approaches can be explored. And so they're not looking at supporting CIG indefinitely into the future, was the message that we got loud and clear. And then, of course, any big program like this has to have a management plan. So if we move forward. So the other thing that we talked about in terms of thinking about this proposal is that many aspects of computing have really changed, certainly since the beginning days of CIG-1, but really even since the proposal for CIG-3. And these things help to shape our thoughts and our discussions as we move forward with CIG-4. So for example, just the literal explosion of open source software that you can now find. We've seen growth of software repositories. So this specific function, which was once fairly important thing that CIG did, has now become somewhat less important, and we need really to be focusing on other things. We've seen evolution and change in the publication standards, the FAIR principles, and this is an evolving target that we'll need to be aware of. And also just trends in the computing, the use of Python, Jupyter notebooks, all of that sort of stuff are things that are have substantially changed. And we wanted to make sure as CIG moved forward that we were taking account of these things and making sure that we would continue to be relevant to the community. So move forward. So the basic elements of the proposal were organized in sort of 4 themes. And so we referred to these as cornerstones. The modeling software part was the sort of standard thing that you normally think of for CIG, developing software tools to address geodynamic scientific questions of interest to the community. And so that's well developed, but you'll be surprised perhaps that sort of the things that we focused on under that heading. But what we also recognized, and actually Wolfgang and Jerome has also mentioned the fact that these problems have become more than just simply running a single code with an input file and collecting some output. That they are part of a much more involved and complicated process. And the idea of providing infrastructures to support these efforts was clearly something that we thought was important and we wanted to call out. And this is probably among the newer things or the newest thing that is part of the CIG-4 proposal. The training and the community building that I think CIG has done very successfully in the past are things that we want to continue to support and hopefully even expand. Next slide, please. So in terms of the modeling software, the thing that probably surprised me most that came out of this effort, there was much greater emphasis on details that I would call shared or common infrastructure. So we didn't spend a lot of time talking about the specific scientific features that we were going to be added to these codes, but rather what would be the things that we could do to enable a much larger community of people to be able to doing these things. So we do focus a little on new capabilities. We talk not so much about the specifics, but how we actually go about making these things happen. And so this will be done through a combination of sub-awards and coding events like the hackathons, and also the introduction of a postdoc program, which is another new element for the CIG4 proposal. We focused a lot of energy on the installation and distribution of software. Part of the plan for dealing with sustainability is related to relying on widely used libraries, which necessarily makes the installation and distribution of the software more of a challenge. And so we recognize the need for tools to make this easier. The idea of code certification and publication is probably one that needs to be a little bit explained. The idea behind this is that we wanted to see more software being distributed and made available through CIG. And we also wanted to avoid issues of sort of CIG ownership of these software. But on the other hand, we also wanted to be sure that the software that CIG was distributing was reliable and useful and met certain minimum standards. And the other point is that there's a number of other groups in the community that are sort of working towards similar goals. And so we saw an opportunity to partner with some of these groups, including the Journal of Open Source Software and AGU publications, to work with them to devise a set of strategies or best practices that software would meet to sort of be suitable for our purposes, suitable for their purposes, and so that it would be more how should I say, multiple avenues for getting codes to be distributed by CIG. So for example, if Josh has sort of published a paper and decides that this is a reliable piece of software, then that gives us a starting point to think about what we need to do in terms of distributing that software as well. And I think the second point of this is that the evolving publication requirements means that we want to be aware of what's happening, but we also want to be sitting at the table discussing how this project or how that goal will move forward. And then we also devoted some attention to emerging computing paradigms, which again is going to be something that I think the postdoc program will try to use to address. So next slide. Okay, so for the computational workflows, this is really the new element, I would say, to the proposal. We have discussed the idea of how we host models, and in particular, how we host entire workflows, how we make those available, how we make those accessible to the community as a whole, and how the community as a whole can make improvements in those and then recycle these back into the repositories for use for other people. And so there's an awful lot of emphasis that has gone into this. There's also the sense that we want to be able to sort of couple models more effectively than we have before. This was one of the grand visions of CIG1, I think. The general consensus was that some generic framework for doing this was probably not the right way to go, but that there would be things that we could do with respect to the design of the individual codes that would make coupling models together more simple, perhaps. So the kinds of things that we're thinking about in terms of ability to integrate and export data, trying to make those things more standardized and similar between the different codes, creating common model configurations so that the expectations of the individual codes are more similar. All of these things are steps in terms of making these codes more interoperable. And that's sort of the direction that this particular section of the proposal takes us. Next slide. Right. In terms of the training, I think CIG, this is something, in my opinion, at least, that CIG has done very well. We want to continue with the user workshops and the training materials. I think there is a recognition that a lot of these materials are done perhaps in an ad hoc way. Perhaps all the different groups are doing variations of this, and that there was some opportunity to collect those materials and have these centrally organized to be useful as learning modules in the computational sciences. And the attraction of this is, of course, that if these materials are then used and they're based on CIG products, then the people that are learning these skills are learning them and having them demonstrated with CIG tools, which is nice. I mean, clearly there's a need to develop more advanced skills, and this is something that's been nicely done with the hackathons, more specialized training, and then the idea of having the postdoc program, which would include either a user or a developer postdoc with that sort of perspective, addressing issues that are relevant to the CIG community as a whole, is something that hopefully will give us a little bit more ability to respond to opportunities. So next slide. Okay, and then the last of the cornerstones was the community building. And again, I think this is something that CIG has done very well. We want to expand the developer base, both within CIG, but as we're reaching out and trying to bring more codes into the CIG repository, we're going to be reaching out to other communities and providing them with the support and the help that's required to make that leap. The outreach will continue, including the speaker programs and undergraduate research opportunities. And there's a place for CIG to play, or a role for CIG to play, in terms of making materials available for these REUs and other efforts to reach out to underrepresented groups. We were explicitly expected to address the justice, equity, diversity, and inclusion. So there's a discussion of that in the proposal. We're also talking about opportunities to promote multidisciplinary collaborations. And I think that there's really a lot of opportunities for synergies between CIG and CIDR, both in terms of educational things, but I think also in terms of just driving basic science. There's great opportunities from having these two groups work a little bit closer together, and then efforts to reach out to the broader scientific community. So next slide, please. Okay, so the sustainability was something that CIG hadn't been asked to do in the past. And the idea here really is to evolve toward a more community-driven development model. The idea is that the principal developers would support the community activities, and so by supporting them, greatly leverage the capabilities that can be added to the code by having this largely run by a community effort. To do this, of course, requires a bit of base level support, and Wolfgang mentioned the fact that this consistent support that he'd had from CIG was sort of an important element in making this possible. And we see this as the way forward actually for moving most of the codes in this direction. Sort of a separate issue connected with sustainability is the increasing reliance on widely used libraries. You're tapping into software that's used by a much broader community than our own and more easily or more likely to be sustained. But this necessarily creates challenges when it comes to actually using, distributing, installing, and running these codes. And so this then links back to the issue of providing greater support and infrastructure for those very tasks. Next slide. Okay, in terms of management, the last point I think I want to touch on is the headquarters will remain at UC Davis. We're going to transition from the single PI to a co-PI, where the activities will be sort of divided between an operations and then an interfacing with the governance of CIG. The technical staff would include 2 staffs and the postdocs mentioned previously, and that we imagine hiring a community manager that would be charged with the tasks of looking after the educational resources and also improving our efforts in diversity. And I think that that's it. So my intent with this really was to try to use as little of the 15 minutes as possible. I don't know how I did, but I would certainly open it up for questions and comments.
Yes, we are running a little bit behind, but we do want to address any of your questions about the CIG4 proposal. It's currently in review right now, so there's not much information we can give you on its status at this point. So I don't see any hands.
Quick question. When do we expect a decision?
So the typical NSF timeline is 6 months. Proposal was submitted in mid-August. 6 months would put us to mid-February. So then our current contract with them, we're in a no-cost extension, runs until the end of July. Other questions? Certainly, if you have other questions, you feel free to contact me or Bruce, and we will.
Well, the other thing I was going to say was that any of the other members of the writing committee, if they want to sort of elaborate or clarify things or alter perhaps, that's also an option I would encourage.
Okay. in lieu of any questions right now, what I like to do is I like to, I think, transition to the breakouts. We are running behind, so we're running about 15 minutes behind. My suggestion would be to maybe just address one of the breakout topics, that is the one on Jedi, and then come back and do the plenary discussion and keep that breakout discussion maybe to about 15 minutes, 10 or 15 minutes. I think it'll naturally sort of blend into the two topics. I think sort of naturally blends in some sense. How does that sound? Does that sound good to you?
So just to be clear, Lorraine, so you want everyone to sort of stay here in this one location and talk both of these topics? I guess
no. What I'm proposing is when we do the breakouts is just to break out and then just discuss the first topic in our breakout groups.
Okay, so you still want to break into two parts, but one topic. Gotcha.
Yeah, exactly. So anyways, on this slide, I have put a coffee cup here, and that's sort of to remind you that these breakout topics are designed to be more as just simple discussions, more, it's a poor substitute for having coffee with somebody or with, just grabbing and starting a conversation in a hall with somebody, but they're supposed to be informal, and you shouldn't really think of them as what we traditionally use breakouts for. But we do want to get feedback from you on these topics. Especially as we transition into a new phase of CIG. Okay, so we have 32 people still with us. We're going to ask you to self-assign and self-assign into 3 groups such that we get balance, and we'll give you about 15 minutes in your groups to discuss the topics. The topic initially was going to be 2 topics. I think we'll limit this to 1, and that's sort of Jedi and belonging and accessibility, actually. And what we want to get some ideas from you is what can CIG uniquely contribute to these movements and efforts. There have been a lot of conversation in other spaces, and I know a lot of you have been involved in those conversations. So we'd like to build on that and kind of come at it from a CIG perspective, but we're also trying to build on your experiences and your thoughts about what that perspective should be and what a focus for a CIG sort of belonging, accessibility, justice, equity, and diversion and inclusion group should focus on. So so we're trying to get some ideas on that. So that will be the charge for the breakouts.